Hello everyone, welcome back to another video. In this video, we'll be solving question number of islands. Now this question has a prerequisite of get connected components. So if you haven't checked that video out already, you probably should. It is just the previous question in the series, right? The link to that would be in the description box. Moving on to the question that we have in hand, which is number of islands, which is a really interesting question, right? If we look at the objective over here, and along with the objective, what I would want to do is grab the input, right? So we have an input array, if we see over here, right? So if we get this input array, right? And if we observe what the question has to say, nah, okay. So the question says that you are given a 2D array where zeros represent the land and ones represent the water. Assume that every cell is linked to north, east, west, and south, right? That means that each and every cell, let's suppose this particular cell is linked to north, east, west, and south, right? So in all the four of the directions, right? Okay. So next it says you are required to find and count the number of islands. Right? So if 1 is my water and zeros are my lands, my islands are the piece of lands that are covered by water. Makes sense? Islands are covered by water. So if this is my water, then I would be surrounded by, if this is my land, I would be surrounded by water, right? So if this blue portion is water and the red portion is land, in this case I have 1, 2 and 3 islands, right? So if we try to visualize this on the given input, we have lands as 0, right? So this part is my land, right? If I draw this more properly, this part is my land. Again, if we see, this is 0, 0, 0. Over here also, this is again my land, right? And then over here also, this whole part is my land. The rest of it all is my water, right? This whole part is my water. What I have to find is the count of number of islands. So the number of islands in this particular test case is 1, 2, and 3. So my output would be 3. Right? I hope you understood the question, right? So the question says we have to count the number of islands, given that zeros represent the land and 1 represent the water, right? And what is an island? An island is a piece of land that is entirely covered by water on all of the 4 sides, right? So if we see 2 is entirely covered with water, right? And what we can also imagine is outside this entire array matrix that we have been given, the outer part would also be water, right? So if we imagine like that, we can more clearly see the 3 pieces of islands now, right? I hope you got the question. Try relating, again, the hint is try relating this question with the question get connected components, right? The concept of get connected components is something that we would be using, right? And also, if you haven't checked that problem out again, please do that. The link to that would be in the description box. Please do that, right? Okay. Moving on to the solution of this question, right? Now, if we see, we have this particular matrix as input, right? We have this particular matrix as input. If I get to 0, and if I can travel to 4 directions, right? So I can travel to my north, east, south, and west, right? So these are the 4 directions. So if I travel from this 0, I can get to this 0, right? If I erase from this 0, I can get to this 0. From this 0, I can get to this 0, right? Because I cannot go to water. If I say that I cannot go to water, only if I'm only allowed to travel on land, only travel on land, right? Then from this 0, I can only go to the west side, right? Now from this 0, I can either go to north or to my east, but both of those zeros are already evaluated, right? Both of those zeros are already visited. That means I can only visit these four zeros if I start from this zero, and I have marked all of these zeros as visited, right? So that means this is my single component. This is my one component, and my one component would correspond to my one island. So this was my first island, right? Then I traverse in the matrix again, and I find next zero. My next zero is over here, right? My next zero is over here. Now from this zero, where can I go? I cannot go to north or west because I have one. I cannot go to east because that would be out of bounds. I would go to south, again to south, again to south, again to south, again to south. Now I cannot even go to south because that's also out of bounds. That means I would terminate from here, and all of these zeros that I have just marked would comprise of my another component, right? So this would be my second component, right? So this is my second island. This would be my first component, first island. This would be my second island. If I again traverse now, I would traverse from 1, and I find this 0, right? Then from this 0, I can go to west, again, east. I again go to east. Now I can only go to south, then again south, right? Now from this 0, I cannot go anywhere. That means all of the zeros that I just visited are part of my third component, which is my third island, right? So as we did in our get connected components, which was GCC, what we did was we took a visited and we traversed through that visited, and as soon as we found a vertex that was unvisited and unevaluated, we called DFS for that, right? And every time we called a DFS, that means we were evaluating a different component, right? So in this question, we have called DFS for a total of 3 times. We have called DFS a total of 3 times. And that is the number of islands that we have. We have a total of 3 islands, right? And in DFS, what we do is we mark our visited as true. So we would get the account that none of the zeros are visited, evaluated again, right? Once they are evaluated, right? I hope you get the high level thinking of this question. Let's try to code this a bit, and we would again revert back to try run, right? So if we see over here, what we have is a array. Now in the matrix, we don't need to form any graph, right? As we have a matrix, just like how we did in floodfill. If you recall floodfill, which was a question in recursion module, we were allowed to travel in 4 directions, and we had to find total paths from the source, which was 0, 0, to destination n cross n, right? And similar to that, what we would do in this case too is travel to all of those 4 directions directly inside the matrix. We won't create any other graph structure, right? Our matrix would be our graph, right? So the very first thing that we need is a Boolean array. Now the Boolean array would be of 2D type because we have a lot of vertices right now, and the vertices are in 2D format. So my vertices Boolean would be visited new Boolean. The size of this would be n cross n, m cross n, right? Over here, if you see, it's m cross n, right? So visited size is m cross n. What we would do is we would traverse in the array. So I would have my I equals to 0 going till m, I plus plus. Then I would have my j, and j goes from 0 till n, and j plus plus. Then over here, what I have to check is check for unevaluated land, right? What is my land? Land is 0. So I would check if my visited of a particular point, which is ij, if it is false. And I have to make sure that it is land, it's not water. I cannot evaluate water, right? So I have to check if my array of ij contains 0, which symbolizes my land, right? So this particular check is for unevaluated land, right? As soon as I get an unevaluated land, I would call for DFS. What is my source? My source is I and j, right? So I have 2 variables that determine my source. Do I need any destination in this case? We don't, right? In get connected components, we only think about traversing in the graph and marking true, right? We don't think about the destination, right? We don't need any destination now. What we have to pass again is array and the visited. right? Now, what I said was every time we call for the DFS, we are evaluating a different island, right? Every time we call for the DFS, we are evaluating a different island. And at the end of the day, in this question, we want the number of islands. So what I can do is I can have a count over here as 0. And every time I'm calling for this DFS, I can increase my count. At the end of it, what I would get in my count is the number of islands, right? I hope it's clear. This is our high level code, right? This is what we just discussed. Let's look at the DFS, right? So the DFS would be same as what we have written up till now. The difference is just that in this case, we instead of the adjacency list, we would be running DFS on a matrix in which we would be allowed to traverse in 4 of the directions, right? So public static, right, void DFS int r int c int array and boolean of visited, right? Now I can call for 4 directions, right? What are those directions? I can either go to the east side, which is right side, which is adding 1 to my column. So I can have c plus 1 over here with array and visited. I can have DFS of then what I can do is I can go downwards, which is increasing my row. So r plus 1, which is south direction, array and visited. Then what I can do is I can go to west. West would be decreasing 1 from the column. So DFS is r comma c minus 1, array and visited. And then at last, what I have to do is decrease my row to go on the north direction. So DFS of r minus 1 and c would be then same array visited, right? Now I've called for all of the neighbors, but I haven't checked if the neighbors were unvisited, right? So in this case, as I have called for all of these without checking, what I can do is I can write a reactive code, right? Up till now, what we did was we checked before calling. That was proactive approach. In this question, what we would be doing is we can check over here that if my visited of r and c is true, then I can return. Also over here, we can also check for out of bounds, right? So what we can do is we can check if r is smaller than 0. This would be or. So if my r is smaller than 0, or if my c is smaller than 0, or if my r becomes any day greater than or equal to array.length, or my c becomes greater than equal to array of 0.length, then in this case I would have to return, right? Because I would be having out of bounds error over here and I would be getting true over here. Other than that, what I also have to do is check if I'm not going on to water. I have to stay on land. So array of r and c, right, if it is equal to 1, that is if I get into water, then also I have to return, right? Now before calling, what I have to do at every given step is mark my visited, which is r and c, as true, right? If we run this, then we should get, yeah, we are getting a runtime error that is on line number 36. We are getting -1 for index of bound. Okay, so we are checking for these at first. What we have to do is check them afterwards, right? This is because we have to make sure that they are inside the bound. So if we run this again, it's accepting the test case. If we submit this for all the test cases, then it should pass, right? So it's passing. We are getting 10 out of 10. So our logic is appropriate, our code is appropriate, right? If we look at this again, what we did was we basically had our high level code, right? So what our high level code had faith was, it said that for every unevaluated land, I would make sure that every piece of land that is connected to me would be marked as true, right? And whenever I was visiting an unevaluated land, I was considering that this is a new land. That's why I was increasing the count. That means this is a new island. I was increasing the count of my islands, right? And my DFS function over here, DFS function over here, what it did was it marked all of the unevaluated land as evaluated after evaluating them, right? For all the 4 directions, right? And we did it using a proactive approach, right? That is, we checked for all of the base cases in starting. We checked for out of bounds in the starting, and only after calling we checked if the current neighbor was marked true or not, right? This is a very reactive approach, right? So I hope you understood how we did this question. I hope you are able to visualize how islands are forming inside the water, which is ones. And I hope you understand the concept of components being islands, right? If you don't clearly understand the concept of GCC, I would request you again to go back and watch that video and then only come on this video and try this question again. So I will see you in the next video. Bye bye.